Now let's look at the third example problem. So this is a encoding decoding problem. So it's a very common string problem. So we have an encoding scheme. So if the input is 0, we will encode that into a dot. And if it's 1, we will encode that into a dash dot. And if it's 2, we'll encode it into dash dash. So I guess this is a little bit similar to Morse code, but of course a lot more simpler because we assume they're only in 3 uh, characters or letters that we want to encode. And the question asks us to decode input string. So for example, if we have a string like that, well, I guess maybe here my input and output is a little bit confusing because it's kind of exactly opposite. So the input are what the output up there. So anyway, when we read this string, if it's we see it's a dot, we know that must be coming from a 0. If we see a dash, then we need to know what's the next one. So the next one is dot. So then dash dot, and that must come from a 1. And then the next one dash dash, that must come from a 2. So similarly, this one dash dash must come from 2, and then the dot must come from the 0. So yeah, similarly, you can work out the decoding of this. So what we need to do is to write the code to decode this. So one, I guess, challenge that one problem that make one aspect that makes this problem challenging is the encoded length for each input character are different. So the 0 is encoded into a length 1 string, and 1 and 2 are encoded into length 2 string. So this creates a number of issues. First is do we know, given a string, there's a unique way to decode? And the answer is yes, because none of this is a is a substring or is a prefix of another. So if start at the beginning, if it's dot, then it must be 0. If it's a dash, then we must take this one and the next one that will be decoded into 1 or 2. So if the 0, for example, also encoded into dash, then we might be in trouble, because if we see a dash, we don't know whether that should be a 0 or that's actually a 1 if the next one is a dot. So there will be ambiguity there. So when each encoded string is not a prefix of another, and then there's no ambiguity. But that still means the code for decoding is a little bit complicated, because or at least a little bit difficult to think about, because the length is different. So if the length is the same, then each time I will always look at a substring of a fixed length, and based on what value it is, I will convert that back into input. So now we need to deal with the case that the substring encoding lengths are different. So I see two natural approaches to do this. The first, it's probably more natural to use a while loop, and then the body of the loop will decode one character. So it will go as far as needed to decode one character in each iteration. And the second approach is we use for loop. So then each iteration will just look at one character at a time. But then we remember what was the last character. And we'll use that if needed. So we remember some extra state information in the loop, and this will help us decode. So let's see the code. So this is the code for the first approach. We will decode one character in each iteration. So we first read in the input, that will just be a string. Then this I will be the indices that we move across a string. And one thing to note is that this I will be incremented different values depending on the string. This is because if we see a dot, then we know this will decode it into 0. So then we just increment I by 1 to look at the next character. On the other hand, if the first letter we're looking at is not dot, then that means it's dash. Then how we decode will depend on what is the next character. So note that here, this if condition, we are checking SI. So we look at the i's character, the current character. If it's dot, we know it's 0. if it's not dot, then it has to be dash. Then we'll look at si plus 1. If it's dot, then that will be 1. If it's a not dot, then that means again that is a dash, then that will be 2. So when we consume one character, we'll just increment I by 1. When we consume 2 characters for the decoding, we will increment I by 2. And also when we print out these numbers, we don't want a new line after each number. So by default, the print will print everything on a new line. So after they printed what we tell it to print, it will add a new line at the end. But we can explicitly tell the print function, don't use the default new line to end your printing function. Use what I give you. And in this case, we give an empty string. So then there's nothing after 0 is printed. Sometimes we use a white space if we want to separate this as numbers. But here, the desired output doesn't have any space in between these 0, 1, 2s. So we specify empty string as the ending for print statement. So that's the first approach, where in every loop we'll decode one character, and we will increment this indices by the length that's needed. So we skip the portion that we already used to decode.